Hello, hello, and welcome everybody to the A-Level Physics Masterclass. This one is called Troubleshooting, and we are going to start off with, well, one or two housekeeping things. So first of all, can I introduce Megan? So this is Megan. She is my admin assistant, also my daughter. Okay, so we're going to do useful stuff for students. Then we're going to do some advice for parents to help parents navigate this A-level journey, because it's quite stressful for them too. Maybe most of you students don't realise it, but I promise you parents get stressed by A-levels too. And then I will offer my tutoring to anybody that wants it. Right, okay, so let's get going. We've got so much to get through. Let's play it from here.
What advice would you give to somebody who is maybe on the fence about taking tutoring?
I would say definitely do it, because I feel as somebody trying to achieve high grades, it can be a bit almost like embarrassing to try and get tutoring because you think you can do it yourself, but there is a point when you do need to get it. So I was thinking about getting it like early on, but then I had this kind of thing in my mind where I was like, I can do it myself, it's okay. But it's not a bad thing to get help. So yeah.
Okay, so if you could advise yourself, say yourself at this time last year,
Yeah.
what would you say to yourself?
I would say just try my hardest to look for the help that I need, because like I feel like I could have gone to my teacher more as well. Look for help in other people. Yeah. So just definitely just don't be scared to ask for help, basically.
Okay.
Right, so advice from Ayat. She's one of my Year 13 students from last year, she advises ask for help sooner rather than later. And your first port of call is obviously not an online tutor like me, but your teacher. So and do make use, if your teacher gives you help, revision help at lunchtimes and stuff. Go along, don't miss out. It's always a good idea. Right. Let's move on. So this is what we're going to be doing. We've got advice from past students. That advice from Aya is not the only advice we're going to share today, but advice from past students. And then we're going to talk about your biggest problems. In the WhatsApp group, I put a survey in there, your biggest problem, and some people actually filled it in, which is good. And I want to share the results of that because they're really very revealing. Okay, I'm going to talk about the importance of exam techniques and how to answer different types of questions, which is one of the things that I promised in the ads that I would do. And I'm going to talk about various different bits of exam technique, particularly ninja question analysis, explain and describe questions, and then we're going to talk about getting your personalized revision plan. So I promised that people who came live would get a bonus, and your personalized revision plan, which I'm hoping I'm going to be able to automate, but at the moment I haven't managed to do that. So this is promising to be quite a lot of work for me. Your personalised revision plan you will get if you fill in a survey form to tell me a bit about what you personally need, so that I'll be able to personalise it, literally. I am hoping that I'm going to be able to do that for everybody. You will also get a work plan, which is not really a work plan. It's a list of papers, but there'll be papers for your exam board. And your year group, so that's absolutely specific to you too, and that you can use those resources to help you with your A-level physics learning. And I've just realised I've got 2 5s and a 6 and a 7. I can't count apparently. Anyway, and then advice for parents, and then you can stay to my tutoring offer at the end. Right, so there is the biggest problems. Right, now I've colour coded them. Electricity, which when I did a survey beginning of the school year, electricity, potential dividers in particular, was the thing that came up the most, actually. So the yellow ones are electricity, and you can see that a number of people do have problems with electricity, but they don't have, I mean, it's not overwhelming, okay? Electric fields, well, fields of all sorts, including capacitors, is the blue. You can see a few people have problems with that. We've got quantum physics in orange. We've got thermal physics in a sort of mustardy brown. We've got pink is mechanics. Practical, one person said practical in a sort of purple. But overwhelmingly, those things in green are all exam techniques. Look at them. Answering the way the exam board wants, how to revise effectively, not understanding the information in the question, not understanding what the question's asking for, applying my knowledge to the question, knowing how to start a question and the wording, understanding the content, but flopping on exam papers. It says the exam questions are especially hard. Applications to questions, I don't know how to apply it. Hard to see a pattern in the mark scheme when I'm doing it. Can you see the common theme here? It is all about the exam techniques, all of it, pretty much. I mean, one or two of you have problems with one or two little bits of physics, but they're really very small bits of physics, even where people have gone into quite a lot of detail about exactly what their particular problem is. It's a small bit of physics. So most of you are fine, actually, with most of your physics. And actually, that's not that surprising. You are all of you incredibly clever people. You cannot, well, nobody chooses to do A-level physics who isn't clever. Nobody chooses to do A-level physics, and if you choose to do A-level physics, you're probably in the top 5% of people in the country already before you've even got your A-level. And when you honestly, none of you that have turned up, especially for turning up on something like this, where you've been given the opportunity to improve yourself, none of you that have turned up, you're not stupid. Every single one of you is a clever bean, but you can see that all of you, or nearly everyone, has a bit of a problem. And the thing is, right, it makes sense, doesn't it? You have a test, a physics test, and you can't do some questions, and you think to yourself, I can't do physics. Physics is really hard. And yeah, it is. I mean, don't get me wrong, physics is really, really hard. It really is. But actually, the problem is exam technique. And it's the problem for nearly everyone. Nearly everyone. Now, this is Michaela's story. And I actually don't want to watch all of it, so I'm going to go and find it. Can you see this link? I'm going to go and find it on YouTube.
Hi.
It is worth joining my YouTube channel, because from about September time, I've started to post fairly regularly, and there's some really useful stuff on there. Right now, I don't want to watch all of this. Obviously, it's there if you do want to watch it all, but I want you to just watch a little bit of this. All Michaela did was our Easter course. She didn't do any other tutoring, and I need you to understand that the Easter course that she did was focused in on two things. The first is exam techniques, and we did them to properly focused on exam techniques. And we also went through what I call the pain points, so the bits of A-level physics that everybody struggles with, things like potential dividers, things like electromagnetic induction, things like capacitors and so on. So, listen to what she has to say. We're not going to watch very much of this, but listen to what she has to say.
It was a fun way to brush up the tougher bits of the course. You felt secure in your exam techniques. Yeah. Lots to go away and think about. It was interactive, and the 6 markers was the best bit.
Yes, and I'm actually going to double back and say the electromagnetism session was really helpful as well. I think it's such a tricky topic, and
yeah, I agree with you 100%. I think the hardest part of A-level physics is electromagnetic induction.
Yeah. And those are the ones they like to ask wacky questions about sometimes when they're
they do weird
papers.
Yeah, they do weird stuff. Yeah. They don't do a normal, electric generator. They have like a weird coil that they move away from as Yeah. Oh, it's like no, yeah. It's always weird stuff. Yeah, you're right.
So that was really helpful. And the 6 markers, I mean, you would not believe the way that my astrophysics 6 markers changed, because like before I was like, oh, I don't even really know what they're asking me. But after we did that session and I really started to knuckle down and do the uncomfortable bit, which is like, don't look at the mark scheme, just try it yourself, use your brain. I really started, I was getting like 2-3 marks maybe when I first started doing astrophysics papers, and I got right the way up to 5 and 6, those last few papers that I did before.
Yeah, because you did the AQA, and that's the where you get the 6 markers is in that option topic.
Right, so you can see then that Michaela was talking, she did everything, all of the exam techniques, and she absolutely made a difference to her grade. She told me, if you want to watch the rest of it, you can see that she was on a B before she did that Easter course, and after 3 weeks, so a week of training and 2 weeks practicing, she was on an A star, and she got an A star in her final exam because she was doing this last year. But you can see that she was like floundering, flipping and flopping, just like one of you who said your biggest problem was that. She was floundering, not being able to pinpoint what she needs to say in order to get the grades and the marks on the wordy questions. Really, those are the main problem. They're not entirely the problem, but they're the main problem, the wordy questions. And she said, in particular, the 6 markers. Now, most of you are doing AQA. There's quite a lot of you doing OCRA, and a handful, who are doing Edexcel. And AQA have 6 marker questions in the option topic, as I just said in that clip. The OCRA have 6 marker questions on paper 2. And you get 2 6 marker questions on paper 2. Those of you who are in year 12 won't know this yet, but you do get 6 marker questions on the AS papers as well. One of them could be about anything, but the other one is nearly always describe an experiment to show. And you've got to be able to answer those questions. Michaela goes on to talk about practical physics, and don't leave things until the last minute when you're practicing your paper 3 and all sorts of useful stuff. So go and watch her because she's brilliant. But I wanted you to see particularly what she'd said about not knowing what to put. And as soon as she knew what to put, having got the training, she was able to pinpoint what she needed to go from 1 and 2 marks on a 6 mark question to 6 out of 6. Now 1 or 2 marks is sort of 30%, but 6 out of 6, wow, 100%, isn't it? 5 out of 6 is into the 80s. So an 80% is an A star all day long. So that's what you need to be aiming for, 5 and 6 out of 6. And it's not that hard. You just have to know what the exam techniques are that you need to follow so that you can answer those questions. Right, now I'm not going to be able to go through all the different types of questions, but I am going to go through as many as I can. Right, so what we're going to do is we're going to talk about how to answer different types of questions. Right, now we're going to start with ninja question analysis, which is how to analyse questions so that you don't miss anything. Now, we're going to do this through the medium of a paper from AQA for paper 1, 2018. Now, obviously, the different exam boards have different papers, and if you're doing OCRA and Edexcel, you're going, oh, it's always AQA. And the truth is that sometimes it is AQA, and more people do AQA than any of the other exam boards. But the questions, I mean, everybody seems to think that the questions are very, very different. And the truth is, they're not. edXL has slightly more of the less common command words. So things like justify and assess and criticize, those sorts of command words come up more on edXL. AQA has way more multiple choice questions, but overwhelmingly the sorts of questions that you get on the main two papers for AQA, OCRA and edXL are very, very similar. The main difference is paper 3. edXL and OCRA have a synoptic paper 3 with an emphasis on practical, and AQA have a paper 3 that's split into 2, a practical paper and the option topic. So that's the main place that they're different, but they all have 6-marker questions. They all have difficult calculation questions. Overwhelmingly, the content is identical, and the command word scaffolds that you need to use in order to figure out what the question is really asking you, what's going to be on the mark scheme, those are the same. So so we are going to do it through the medium, if you like, of the AQA paper, paper 1, and I've chosen 2018 just randomly right now. Paper 1, because the content is based on year 12 work. So although it's a proper A-level paper, the year 12s ought to be able to access at least some of it, I hope, mostly. So but please don't give up. If it's a topic that you haven't yet learned in year 12, don't give up. You'll be amazed how far you can get with a data sheet and a bit of logic. Seriously. And the important thing here is not that you learn the physics. Your teachers will teach you that. The important thing here is that you learn the exam techniques. That's what's going to make the difference to your ability to answer those questions. Right. So now, also on this worksheet, there is, can you see, all these different exam techniques? Right, now, like I said, I can't go through them all. I'm going to start with a Ninja question analysis. On my website, there is a page called Free Stuff. And on my Free Stuff page, guess what? There's,
are you an A-level?
There's free stuff, okay? Including a masterclass on Monday night, funnily enough. But anyway, right, if you want to know more about the Ninja question analysis, then the Fields and Forces masterclass is the place to go. Okay, this goes through it in detail, and then I use it over and over and over again. And it's 2 hours long, I warn you. So watch it on speed and a half, and stop when you get bored. But seriously, that this is where you go to get good at Ninja question analysis. Okay, and you should practice it. Once you know the technique, you should practice it every time you do a question. Seriously. And so that it becomes a habit. I mean, it's very difficult to break the habit of skim reading, and that's the problem. Everybody who is intelligent, and that includes all of you, everybody who skim reads, and so you miss things like the words each second at the end of a sentence, and that turns what was an energy question into a power question. And and so on. I mean, I go over it in quite some detail. So Ninja question analysis is practiced in the Fields and Forces masterclass. It's totally free on my free staff page. Okay, so let me go back to here, and oops, this one, and then the walkthrough with a twist is in my Easter course. Problem solving exposed. This is what to do when you don't know what to do. That's for difficult calculation questions. Command word scaffolds, I'm going to go through the main 2 of those today. Improving your odds in multiple choice. Right, to do improving your odds in multiple choice, you should go to the Autumn Accelerator. Again, free video. Again, I start with the Ninja question analysis. This is 2 years old, this Autumn Accelerator now. So scoot through to about 53 minutes in, I think it is. And there is a section on improving your odds in multiple choice. Particularly useful for AQA students, okay? But useful for everyone. Multiple choice questions in A-level physics are very hard and they take too long. And this is a way of speeding things up. It basically, and you're not going to believe this, I'm a physics teacher, really what you've got to do is you've got to eliminate the obvious wrong answers and then guess. And you're like, what, guess? What? Seriously. Obviously that will only take you so far. It takes you maybe as far as a B. If, however, you use that technique, then when you are actually doing the questions, which you have to do if you want to get an A or an A star, then it becomes, you only have to do the questions so far as to distinguish between the two options maybe that you've still got left after eliminating the obvious wrong answers, which means that you can skip steps. It makes it faster. Okay, so go look at the Autumn Accelerator Masterclass, 53 minutes in, I think it's about that, and watch the stuff on multiple choice. All right, so that's improving your odds in multiple choice. Then we've got 6 mark questions. Again, I'm not, I'll try, I'll see if I can do some of that because it's actually so powerful. I mean, you heard what Michaela said about the 6 markers. That I'll see if I can do some of that. Then we're going to do how to revise, and then the game plan or timing, we're not going to be doing that, okay? Not today. All of these exam techniques, they're all in my exam techniques courses, and you do need to get good at everything. And most of you are not even aware that there are exam techniques and that you haven't got them. That is why you are struggling with exam questions. Okay, and then we're going to do help for parents, and then there's the bonus revision questionnaire, plan questionnaire thing, and then, well, we'll talk about the work plans later on, and then there's offers on my next page. Right, okay, so let me go back to the paper that we're going to go through. Right, where is it? Is it that one? There it is. Okay, so this is then an AQA A-level physics paper. This one's from June 2018, you can see, and this is a full-blown A-level paper. Okay, so we're going to start then with a little bit of our exam, Ninja exam question analysis, exam technique. Okay, so the very first thing you've got to do is you've got to not skim read. And in order to stop you from skim reading, I recommend that you use a highlighter pen and actually print out your papers, do them on paper. Unless you're going to be using a computer in your exam, you need to practice writing on paper. Now, obviously, I can't do that on my screen in front of you during an online webinar, but when you are doing your real papers, that's what you absolutely should do. And you are allowed to use a highlighter in the question on your real paper. You're not allowed to use a highlighter in the answers. And the reason for that is absolutely sensible. They scan the papers in and the highlighter pen doesn't show. So you're not allowed to use a highlighter in the answer, but you are allowed to use one in the question. And the reason for doing that is to slow you down. So first of all, I'm going to bring up my highlighter pen. So I'm going to get myself a highlighter pen. I'm going to make it yellow, the classic yellow highlighter pen. And the first thing you've got to do is to find your command word. Where is the command word for this question? Pop it in the chat.
Oh, we got a couple already.
Yes.
Oh yeah. Oh yeah. Oh, all caps as well.
Determine. Right, there it is, the command word determine. Everybody got it. Excellent. Right, now, so determine is our command word. Okay, what is the difference between determine and calculate? Can anybody tell me? The same thing. Good answer, but actually, no. It's not an inference. There we go. Somebody knows. Okay, so Dorothy, determine is use information from the graph. Determine is use a graph. Determine is use the graph. In fact, determine is so intimately, I'm going to stop sharing this a minute. The determine is so intimately, determine and graphs, that they go together like this. In fact, they use the word determine when you have to provide the graph. And if you see the word determine and you can't see the graph, you should go, oh, where's the graph? Seriously, they're that closely linked. Very occasionally, they'll use the word determine when you've got to get your data from a table or from maybe a scale diagram. But overwhelmingly, the word determine is used exclusively when you need to get at least one of the numbers for your calculation from a graph. So basically, it's a calculation, but you need to use some data from the graph, and it might be the gradient or the area under the graph, or it might be reading a particular value off, or it might be the y-intercept or the x-intercept, or it could be anything, any part of it, but you do have to get at least some numbers, one at least, from a graph. That's when they use the word determine. Okay, which is quite interesting, isn't it? Okay, I'm gonna share my screen again. Okay, so you're already learning some exam techniques because the words on exam papers tell you what to do. Seriously, they're written in English. You just have to understand what the words mean. Okay, determine means get your numbers from the graph, right? So now the next thing in our ninja question analysis, we haven't read anything yet. We've got our command word. We need the number of marks, please. How many marks? Pop it in the chat. 3, 3, 3, 3, 3. Yes, there it is. 3 marks. Perfect. Okay. Right, now, the next thing that you need to do is you've got to figure out what the question's about. So I would like for you all, please, to pop into the chat. What is the topic of this question? What is the topic of the question? Oh, we got mechanics, forces, mechanics, forces, mechanics, forces. Okay, I agree. So it's mechanics.
Someone said Suvat.
It might be Suvat, maybe. Okay, so I mean, Suvat is part of mechanics, isn't it? It's part of forces. Okay.
Newton's second law.
Whoa, yeah, okay. Newton's second law is,
Velocity time graph.
Okay, velocity time graph. Yep. All of these, they're all mechanics, aren't they?
Impulse, someone said.
Impulse is not this. Impulse is force times time. Might go on to ask about impulse. I haven't seen further down the question, can't remember it. So, but I mean, impulse is mechanics, but this in particular is Newton's second law. And okay, I agree, actually. Right, Newton's second law is normally written like this. Newton never said this. Newton said this. Well, he said change in momentum over change in time. So, but actually what he did was he said F times T is equal to delta mv. That is the impulse.
You get a gold
and that
star.
is a change in momentum Okay, so
Just before you said that, someone put in FT equals MV question mark.
yep.
They get a gold star.
Well, okay, is it about that though? I mean, it's definitely mechanics. We've definitely got a speed time graph. We've definitely got, well, it's F equals ma because they're asking about the force decelerating. I mean, well, we haven't read it yet, but I noticed that. I did notice that. Okay, so we've got our topic then. Our topic is mechanics. Okay, right now, what the next thing, right? And I'm hoping that all of you got my messages on the WhatsApp chat. Please bring along your data sheet. Okay. Again, I'm going to stop sharing my screen. Right now, this is a bugbear of mine. Right, you have to know your data sheet. And I don't mean you have to know the individual equations. That's not what I'm saying. What I'm saying is that for all of those individual equations that you haven't got to remember because they're there, they give them to you on the data sheet. But every single equation has got letters, variables in, you know, the algebra. And every single letter is used more than once for different things.
Because they just aren't enough.
There just aren't enough. I mean, even the Greek ones are used more than once. The curly E that is strain, okay, is also EMF. And it's also the emissivity, if it's got a little zero, of free space, and if it's got a little r of it's the relative emissivity, which is also called dielectric constant. And so on. I mean, you know, it's just nuts. That's a Greek letter. I mean, lambda is used for wavelength, also used for the decay constant for radioactive decay. Okay. Little c. Can anybody tell me what little c might be? Give me some examples of what little c is. Pop them in the chat. Yeah, speed of light. Okay, I want a different one. Not the speed of light, a different one. What might little c? The charge on an electron is a little e. Did you mishear me? Coulomb, yeah, but that's a big C because he is a man. It was his name, so he needs a capital C for Coulomb, and that's a unit. So I want a symbol for a variable. Little c. Oh, Sidra got it. Specific heat capacity. Yep. Also, the speed of a particle in thermal physics. How many 13s here? Yeah. Okay, so specific heat capacity is little c, and speed of a particle, yeah, and the speed of light. Okay, what about capital T? Oh, root mean square speed. There we go. Oh, it might also be the speed of sound. Yeah, in ultrasound equation. Okay, capital T, what does it mean? Time period, temperature, absolute temperature, tension, yes. Okay, yep, you see? Can you see? All of them. Capital A, what's an A? Oh, torque, I like that one. Capital A, amps, yeah, that's a unit again. I want amplitude, yes. Acceleration is a little a usually. Activity, yes. Yeah, activity. Area, oh, somebody got area. Activity, yeah. Amplitude, yeah, it's also the mass number. Too many meanings. Right, now, this is what I mean by you need to know your data sheet. So you have to be able to look at an equation with no context, just look at an equation and say, right, well, that mu is the mass per unit length. And the T in that same equation is tension, and L is length, F is frequency, and the F in that equation, that one's a force. and so on. You need to know what the symbols stand for. You haven't got to remember the actual equations, but you've got to be able to look at an equation and go, that means that, that means that, that means that, that means that. And it's especially difficult for the symbols which have got more than one name, but the meaning is essentially the same. So omega, a Greek letter omega, it looks like a curly lowercase w. And a Greek letter omega is the angular speed.
Circular motion.
But it's also the angular velocity. And it's also the angular frequency. And those three things are the same thing. They've got different names, but the same thing. And when you properly know what all of the symbols mean, and you know the difference between them, and where you've got more than one name for the same thing, B, capital B, is magnetic field strength. It's also flux density. It's the same thing. The same thing. Okay, and you mustn't get confused, and it's so easy to get confused, and this is what I mean by you need to know your data sheet. Right, now you should have your data sheet open, because the next bit of my ninja question analysis is to open your data sheet at the equations for the topic for the question. Right, so our question, the topic is mechanics. So I'm going to write down F equals ma. I want you to find on your data sheet, if you've got it, paper data sheet, have it open it in front of you at the right place. Now, this is a crucial exam technique. When you are doing any homework, when you are doing any A-level questions of any sort, practice or in a real thing, or in a mock, or in a, practicing in your home, on your desk in your bedroom, wherever it is, you should have your data sheet to hand, and you should open your data sheet to the right page so that the right equations for the topic that the question that you're looking at refer to are there, literally in front of you, so that it's easy for you to look across and go, well, which equation's got A in it for my decelerating? Okay, right, so far we've found our determine command word, we found our number of marks, we found our topic, and now the next thing you've got to do is find all the numbers. Okay, so, and I'm going to go through, I think there's a number there. There's obviously lots of numbers in the graph. There's another number there. And I think those are all the numbers. Okay, so now what I'm going to do, again, ninja question analysis. Can you see I'm not reading this question? I'm analysing it. I'm looking for clues. Okay, I want to go through this, and I want to find the words that mean numbers. So things like the word horizontal, or at rest, or negligible, or those ones, right? So let's go looking through. The prick to how the unpowered. That's a number, doesn't that tells you there's no driving force. Can you see? Ooh. Ooh. Okay, and the vehicle comes to rest. It comes to a speed of 0. That's a number. Right, okay. What else? I think that might be it. Can anybody spot any others? Maybe the 1 in figure 1. What if you don't have a data sheet? Oh, well, which board are you on, Siva? Pop it in the chat, which exam board, and I'll send you one right now.
I can do it.
You know where they are?
I can find them online.
Well, yeah, I mean, they're in the Google Drive. But anyway, right, okay.
OCI.
Okay, so yeah, you need to have your data sheet. Right, okay, we've done all the numbers. Right, now, the next thing we're going to do, and we haven't done it yet, is we're actually going to read the question. We're going to read the question for meaning. And when you are reading a question for meaning, what I would like you to do is I would like for you, please, to draw a diagram, simplistic diagram. A cow is a box with the word cow in it. You haven't got to make it look like a cow, that sort of diagram, right? I want you to draw a diagram of what is going on. Okay, so Right, horizontal escape lanes. Right, does anybody actually know what an escape lane is? Oh, I missed the word horizontal. Ooh, that's a number. But anyway, right, so when you come down a mountain and you've got zigzags, hairpins, because you're coming down the mountain, right? Especially very heavy vehicles, things like lorries and stuff, their brakes begin to fade. Basically, their brakes get really hot. And when the brakes get hot, the brake pads don't have the same friction. It pulls the surface off things, and basically their brakes fail. And so you're coming downhill, and suddenly you lose your brakes. And so instead of going round the next hairpin, there is an escape lane. I need to make it a different colour. Right, my escape lane there is in pink, and it's gravelly, so I'm going to make it a bit dotty. Right, and here is my lorry, and its brakes have failed. Right, and instead of going round the hairpin, it goes into the escape lane, and it kind of crunches into the gravel, and it comes to a safe stop. Ideally, that's what we're doing. Okay, so I'm drawing the situation so I can understand. It might not be gravel. You're quite right. It might not be gravel.
The reason I know that they might ask you to compare two different escape lanes is because I have marked
this paper
this paper where it asks you to compare two different escape lanes, and it isn't a hard shoulder. No, it's separate,
right. Okay,
it's separate from the causeway.
Right. So at this point we obviously have to. Right, I'm just going to clear my drawings a minute so we can have a little look. At this point we obviously have to pull up an escape lane, don't we? Oh, why did that not work? Okay, so we want an image of an escape lane. So there is an escape lane. Can you see? It's not a hard shoulder. The hard shoulder carries on down next to the road. It's a gravel filled.
Potentially.
Yeah, potentially a gravel filled area that's pretty level. And if you've lost your brakes, then you drive in there and you stop safely. Okay, is that okay? It's not the hard shoulder. This I don't know if you can see my pointer. Right, this is the hard shoulder, and this is the escape lane. And it's all soft. This is made from soft gravel, this one. You can see that it's got sort of ridges and stuff in it, and the car kind of squishes in. Okay. Why is my little thing up? Right, yeah, that's better. Right, so can I do Control Z? Poo, it won't let me. Maybe it will. Go back in there. There we go. Right. Okay, so that's an escape lane. Right. Okay, let's close those two. Don't need those open. Right. That's the wrong page. Is it that one? Nope. That one. Get it. There we go. Right. So we are reading for meaning. Okay. So the escape lane made of loose gravel has been constructed at the side of some roads on steep hills so this vehicle can stop safely when the brakes fail. So we've drawn that situation. Figure 1 shows an engineer's prediction of how the speed of an unpowered vehicle of that mass will vary with time as a vehicle comes to rest. So it goes from a speed of, it looks like 17.5 meters per second down to 0, and it's not linear. Okay. Right, it then says determine, so we've got to get some numbers from the graph, the force decelerating the vehicle 2 seconds after entering the escape lane. So we are going to use this equation. How do we know that this is the equation that we need to use?
Oh boy.
Right, mass is given. Yeah, right. We have got, right, can you see? We've been asked to work out a force. We've been told about deceleration. And we've been given the mass. and it's the only other number we've been given. So can you see it's F, A and M? Now try and find the right equation on your data sheet. How easy is that? Can you see? It's dead easy, right? Dead easy. Okay, so we are going to use F is equal to MA. Right, now, we have got to determine A at 2 seconds. What have we got to do with our graph? We've got to use a graph. It's a determine. Determine means use a graph. What are we going to do with our graph? Can anybody tell me? Pop it in the chat.
Draw tangent, gradient, tangent at 2 seconds. Draw a
Yeah,
tangent.
we have to draw the gradient at 2 seconds. Right, if it was a straight line graph, then the gradient would give us the acceleration. Well, the gradient still does, but the gradient is changing with time. So we've got to draw a tangent at 2 seconds. Right now, and I spotted a question earlier. Why have I highlighted horizontal? I've highlighted horizontal because horizontal is telling you a number. Directions are numbers. Vectors have direction. So knowing the direction of something is like knowing a number. So horizontal is a number. Okay? That's
well,
why.
and also, as I said, that you don't have to take into account the angle.
Right, now the next thing I'm going to do then is I am going to draw the tangent at t is 2 seconds. Right, now that is t is 2 seconds, and you'll notice I've gone for a thinner pen. You should have in your equipment a 30 centimetre ruler that is completely see-through, please. Make sure you have one with you in your exam. Okay, we're going to draw the tangent right now. It's actually quite difficult to do this on a screen.
Yes.
So...
And as Abdul says, use a sharp pencil.
Yeah,
if you get it wrong, you can't rub it out.
Right, now that is not in quite the right place. I need to make it a bit steeper. Okay, the reason I can tell is because, right, if you look, can you see that it's sort of touching to there, and it's sort of actually it's not bad, is it?
I'd say it's not awful.
Okay,
Especially for not using.
Yeah, for not actually using. I'm going to leave it like that. That's good enough. So I've drawn the tangent at t is 2 seconds. Right, now, you will notice that my tangent goes right from one end of the graph right the way to the other edge of the graph. Whoever's drawing in red on my screen, could you stop, please? Okay, we're going right from one edge of the graph right the way to the other edge of the graph. Now, you might not think it makes a difference to your calculation when you are using a big triangle compared to a small triangle, but you do need to pay attention to the size of your triangle. Right, now, they give an uncertainty in exams, so don't worry too much. Okay.
But still try to be accurate. That doesn't mean that you can just...
If you don't worry enough, my love, you will find yourself outside the tolerance, especially if you use a small triangle. So we're going to use a big triangle, and we are going to write down our calculation for our gradient this way, because if you always write it this way, then you will always be able to get any credit for having a big enough triangle, and it will make it clear for the examiner and for you when you come back and check your own work how you did it. Okay, so your gradient, you write down like this, is equal to change in y over change in x is equal to, and then you do y1 minus y2 over x1 minus x2. Okay, right, now I'm going to then write underneath, right, so y1, this is it. Can you see? It's there. It's that number there. So it's 14.5. Okay, so 14.5 minus nothing divided by, and I've got 5.7 minus nothing. Right, now I have deliberately done the big number minus the small number for both x and y, but that is sloping downhill, that line, which means that it is actually a negative gradient. So really what I ought to do is minus the first one and add the second one. Okay, if I do that with just one of the numbers, just the y one, you end up with the correct gradient, positive or negative, I mean. Okay, so now the gradient, how do we know that the gradient is our acceleration? We use our GCSE knowledge. Those of you doing A-level physics know that the gradient of a speed time graph is the acceleration, dv by dt, yeah? And gradient is the differential. To go the other way, if we needed to find the distance, we have to go find the area under the graph, don't we? Oh, do you think that might come up later? I think it might. Okay, right, so so this is how we do it. Right, now, having got the gradient, that's not enough. We've still got to work out the force. The question asks for the force. Okay, so let's do the gradient. What is the gradient? Has somebody done it? 14.5.
See if you can do it faster than Alison. Kicker is that Alison's done this question before.
Well, I don't remember the numbers. 2.49 I've got. So 2.49. This is, there's no exponent or multiplier on either axis. So that is it. So it's 2.49 and it's meters per second squared, isn't it? Because it's the acceleration. Right, now, and technically it's negative, meaning it's a deceleration. Okay. How shouldn't the gradient be negative? Well, it should be negative. There will be a recording after the meeting. Right. Right. You might not get it for a couple of days. I have to edit it.
I'm answering it. Carry on.
Okay. Right, now, we're then going to do F is equal to MA. And so we do 1.8 times 10 to the 4 up from up here times 2.49. Okay. Right, now. They have called it a deceleration, so it doesn't matter if you put the minus in or not. If it's a deceleration, you're writing D instead of AC, okay, instead of the minus sign. But it won't matter. If you put the minus in, it's right. If you don't put the minus in, it's right. The force is in the opposite direction to the direction of travel, is what it means. And the acceleration is in the opposite direction to the direction of travel. That's why the force stops the lorry, right? So, right, so it's 1.8 times 10 to the 4 times 2.49. And we get 44820, 44820 newtons. How many significant figures should I use?
2, 2, 2, 2.
How do you know that it's 2? You're right, it's 2. Smallest, same as in the question, yeah. We've got 2 significant figures in our mass, so we need to work to 2. Okay? So this should be 45000 newtons. Okay, 45000 newtons. Okay. Right, now, I could go on and talk about the rest of the question. I don't want to do that. That is the essence of the ninja question analysis. Okay, so the various steps are these. Find your command word. Find the number of marks. Find all the numbers. Find all the words that mean numbers. Find the topic and open your data sheet to the right equations. Read for meaning. Draw the situation, that is arising as you read for meaning. Then look at the question you've been asked. What variables do you have? I mean, I actually drew out which variables we'd got. We'd got F, we'd got A, because of the graph, and we'd got M. Can you see how easy it made figuring out which equation we had to use? So then you figure out which equation. Right now, would this really take 3 minutes? Yes, once you practice doing it. Yes, I know that I've gone through this and it's taken about 40 minutes. But the point is not that this question's 40 minutes. I want you not to be able to answer this question in 3 minutes. I want you to be able to answer any question using these facilities so that you know what the question's really asking you. So you don't miss clues. The more you practice this, the quicker you go. Honestly, truly. And you don't miss things and you don't misunderstand questions. And suddenly you're able to understand what the question's really asking for. How useful is that? Okay, so yeah, we took ages, but we went through it really slowly. And the next time you'll be quicker, and the next time you'll be quicker. You got to go away and you've got to practice this. Right now, I am going to talk about practicing things a little bit, actually, because right, one of the things that pretty much every physics teacher has ever said is the way you get better at doing A-level physics questions is by doing A-level physics questions. Just practice papers. Practice papers. And some of you, particularly those in year 13, have done quite a lot of papers. Some of you haven't done enough. Some of you haven't done hardly any, but practicing papers on its own is not going to solve your problem if when you can't do a question you think it's physics, and it's not the physics that you're misunderstanding. It's how to read the question so that you don't misunderstand anything, so you don't miss the clues. If it's how to structure your answer so that you get the things that are on the mark scheme every time. Can you see, if you are missing exam techniques, doesn't matter how many papers you practice, because you're not learning the right things to fill in the holes in your knowledge. Most people have a really good foundation of physics because that's what your teachers are stuffing into your head all day, every day in your regular lessons during the week. And then there's a sort of doily of exam techniques. One or two of you know a few. But there's great holes in your exam techniques. Now you've got to fill in the holes in your exam techniques. And if you can fill in the holes in your exam techniques and the occasional hole in your physics, right, then you'll be able to answer the questions. Now you get good at doing things that you practice. And answering exam questions is the only thing you've got to get good at. There are 0 marks in the exam for the person that watched the most physics videos. There are 0 marks in the exam for the most beautiful set of notes in the country. There are 0 marks for the person that made the most creative flashcards. None, no marks. There's no marks for the person that wrote notes on their notes most effectively. There's no marks for the person that sat and read their textbook diligently from cover to cover. No marks. The only thing you get marks for is being able to answer the questions. So you've got to practice them. You get better at the things that you practice. But you have got to practice the right things. So when you can't do an A-level question, you've got to figure out what it was you didn't know. And of course, everybody thinks that when they can't do an A-level question, it's the physics that they don't know. But I promise you, you're all of you so clever. The physics isn't a problem most of the time. Occasionally, yeah. But most of the time, the problem is you don't have a clue how to answer an explain question, for example. I mean, in that biggest problem, it was I flip and flop. I understand the content. I don't know how to start answering an explain question. Okay, so we're going to move on to explaining questions.
Well, before you move on, I have someone who asked why you changed the equation of the gradient, where you went from plus to minus and.
Well, it was sloping downhill. So it should be a negative gradient, right? Right. One of the problems with A-level physics is the negatives. Whenever a number is negative, it becomes exponentially more difficult to think about. Gravitational potentials are negative. It's difficult to think about. Binding energy is energy that isn't in the nucleus. It's energy that's missing. It's negative. It's difficult to think about. Anything that's negative is difficult to think about. So when I do gradients, I always go, well, it's sloping downhill. So it's negative. So now all I need to do is do the big number minus the small number for both at x and y. And then I can make it negative by just making a negative on the top. So I just made the top two numbers negative from what they were. And then I end up with the correct gradient. You can do the same thing with thermal physics. So those of you who are in year 13, you need to think about whether the heat is coming into whatever it is you're thinking about, the ice cube, or going out of whatever it is you think about, like the glass of Coke. So the glass of Coke is going to be cooling down, and the ice cube is going to be warming up. So those two numbers, one of them is positive and one of them is negative, right? But it's much easier to go, well, the heat from one is provided to the other. So the size of them is the same. So if I say this one's equal to this one and make them both positive, it's less confusing. There's fewer negatives. I mean, you could just go, yeah, the heat going out of the Coke, I'm going to make that one negative. So I'll start with the heat going into the ice and I'll take away the heat going out of the Coke, and then that is equal to 0 because I can't invent energy from anywhere, right? Well, that would work as well. As soon as you put the negative one on the other side, it becomes positive. Yay! I just start with them both positive, right? Makes it easier to think about. No negatives. So when you're doing a temperature change for MC delta theta, for example, your temperature change, you always start with the hotter temperature, the bigger temperature, because then your number is always positive. And then you have to think logically, right, well, is this heat going in or out? So I'll put my heat going in on one side and my heat going out on the other. Okay, so that kind of makes sense. Yeah, hopefully. Right, next one. Let's move on. Where were we? Let me share my screen again, and then let's start my slideshow again. Right, current slide. So we've done the ninja question reading. So then this next one is about how to answer different types of questions. So this is very anecdotal. I think I just did one AQA, one edXL and one OCR paper. And I just counted the number of explain, calculate, state, determine, show that questions. Okay, and you can see that explain is top of the pile. Now, of course, calculate comes in various flavours, doesn't it? So there's calculate, there's determine, there's show that, there's also derive, there's also deduce, that kind of calculate questions. And obviously that little calculate pile is bigger than any of the others if you put all of them together. Okay, so obviously calculate questions come right up there in A-level physics. Okay, but the next most common command word is explain by country mile. And after that, it's describe. Okay, so, because determines a calculate, remember. Look at those. Right, the state is only ever worth 1 mark, so let's just ignore it. Okay, so explain and then describe are the next two most common command words after all the calculate ones.
And the bane of any A-level physics student.
Yeah, and explain is the single hardest question type to answer.
Evil.
So we are going to talk about command word scaffolds. So command word scaffolds are the structure of the answer. And all explain questions have the same answer structure. And once you know it, all of this, I don't know how to start answering a question or explain, and you kind of just throw the spaghetti at the wall and hope that some of it sticks, and then you're surprised or dismayed when your question, your answer comments do come up in the mark scheme, or they don't. Okay, whichever way, you shouldn't be guessing. You should be able to figure it out, right? Physics is logical, but in order for you to figure it out, you've got to know the structure of an explain answer. Once you know the structure of an explain answer, you can say, well, I've got to say that, I've got to say that, and I have to say that. And lo and behold, those are the three things that are on the mark scheme. Yay! Right, okay, so the structure, are you ready? Pad of paper, write it down. It's really simple. Okay, are you ready? Some people already got it. You can still answer in bullet points. Yeah, bullet points. Right, physics teachers, and physics teachers overwhelmingly are the examiners, they like bullet points. They like you to answer in bullet points, seriously. Bullet points is fine. But right now, explain then. Are you ready for this structure? It's so simple.
Well, they no longer do spag marks for science A level.
That's not quite true.
Okay.
That's not quite true. They're kind of incorporated into the mark schemes for the long questions.
Yeah.
And in fact, OCRA have got little asterisks next to the questions where they're going to judge your quality of written communication. WOC or something, yeah. QWOC, quack. Yeah. Anyway, so you do have to write whole sentences, but you can make them bullet points. You just don't put the little blob, right? Yeah.
And if you want to do bullet points and then flesh it out later so that you can just refer back to the bullet points, write out the bullet points and then write it out properly and then strike through it. You won't get marked on stuff that you've struck through. That's
true. She's an examiner. Not an examiner, an invigilator. She's a trained invigilator. Sorry, not an examiner. Anyway, right, okay. So this is the structure of explain. Right, you ready? It's easy. Key fact, consequence. That's it.
Done. End of masterclass.
And in physics, you get 1 mark for each key fact and 1 mark for each consequence. And in physics, key fact is often an equation. So, trivial example, explain why the car accelerates. Now, why, I don't know if you're aware of it, is an explain. Explain why, right? Why is an explain question, but explain why the car accelerates, right? You've got no context, you haven't got an actual question, but explain is key fact consequence. So, what's the equation? We just used it, guys. Yes. F equals ma, yeah. Okay. So you're explain why the car accelerates. You say, well, F equals ma. And F is not 0, so A is not 0. Now,
has a mass.
Now, nearly never can you just say F is not 0. F is the resultant force. So you have to show that the resultant force is not 0. So you would go, I don't know, the driving force minus the drag or something, right, is not 0. So A is not 0, so it's accelerating. Can you see the structure, though? It's key fact, consequence. There is an unbalanced force, yes, but that's not enough. You can't just say there's an unbalanced force. You have to give the key fact first. You have to say what the unbalanced force will do. So you have to give the F equals ma key fact. That's a fact, right? And yeah? By consequence, do you mean as a result of the key fact? Yes, of course. Yes, I mean, you know, if I say F equals ma and then I say my door is open, what? Right? Can you see it doesn't Doesn't work. It's got to be as a consequence of a force. So you'd have to say there's this force on the door, a resultant force on the door opening, right, or something, right? So you've got, it's a consequence of the key fact. Right, so now with equations, it's relatively straightforward, but most explains are not. They're not equations. So the one I always use when I have little chats with people, free demos, is this one, and some of you might have seen my cat Derek in some of my social media. I don't have a cat, but my cat Derek is he features. Okay, so this is the explain question you've been asked, right? Your mum says, explain to me why your bedroom carpet is wet. So you have to explain, right? It's an explain. What's your key fact? Well, you've got to explain why something's wet. So key fact, it's probably going to be the source of the water, right? Now, you say then, well, Mum, I had a glass of water on my bedside table. Key fact. And there's the second key fact, my cat Derek. And Derek got into my bedroom, Mum. And the consequence is, Derek did what cats do and knocked off the water, didn't he? And now the bedroom carpet's wet. Right, now you can see the structure. And yes, if it's 3 marks, it's either 2 key facts or 2 consequences. And quite often, the first consequence is the key fact for the next consequence. And you get stacks of key fact consequence. 1 mark for each key fact, 1 mark for each consequence. And all you've got to do, most of the time, is to get as many key facts or consequences as there are marks in the question. So it will say maximum of 3, and it will give you 5 options in the mark scheme. But it becomes relatively straightforward. If you're explaining why your bedroom carpet's wet, you've really got to start with the thing that's the source of the water. And of course, you have to pick the right key fact. I mean, it might be that your bedroom carpet is wet, not because of a glass of water on your bedside table, but because there's a hole in the roof and it rained. 2 key facts, different key facts. Okay, so you've got to get the right key facts, and you have to get the right consequences, and you have to get the right number of key facts and the right number of consequences. But suddenly it becomes clinical. You say, right, well, I've got to explain why I have no photoelectrons emitted when I've got intense red light hitting my surface of my metal, but I've got really pathetic blue light, and I do get electrons emitted. I've got to explain these observations. That's one of the classics in a photoelectric effect question. Okay, key fact. What's the key fact here? In the photoelectric experiment thing, why does the blue light mean that you end up with electrons, and red light, even really intense red light, you get nothing? The frequency of the blue light is higher than that of the red. Yes, but that's not the key fact. We've got a threshold frequency. Yes, also not the starting point. Kind of step back a bit.
Might it be an equation, maybe?
Sam's got it. Sam's got it. Sam's got it. Yes. You need to go back 1 step, okay? You're right, it's the frequency and the wavelength. Yes. You're right, it's about the threshold. Yes. But the threshold is only relevant because, and this is why we teach the photoelectric effect, light comes in lumps. We call them photons. And we choose to teach the photoelectric effect because it is the quantum theory, okay? The idea that stuff comes in lumps, right? And in your explanation, and this is why you have to practice these things, because you must include, it always comes up in the photoelectric effect when you're explaining things. One photon interacts with one electron. It's always there. That key fact. One photon interacts with one electron. So you start off with, well, photon energy E equals HF. So the blue light, higher frequency, bigger energy for the photon. And then you can start talking about one-to-one interaction with one photon can only interact with one electron. And then if your photon energy is less than the work function, then you end up with nothing. But if it's above, HF is above the work function, then an electron can be emitted. Can you see the structure though? Right? Can you see it? And you end up with a threshold frequency when the energy of the photon equals the work function. That's the point at which suddenly you start getting something. Okay? The idea though, the key idea, the key fact is that photons are lumps of light. Light energy comes in lumps.
Sometimes.
That all the time, and also waves.
Yeah.
But I won that one.
No. The reason I say it is because someone said, could you
not debate the wave particle duality of light? You could, but only if they ask you to.
That's exactly what I said. The question is asking for.
If they've asked you to explain the observations, no. This is absolutely crucial, lovely people. This is absolutely crucial. You must understand that you must do what the question asks you to do. So explain is key fact, consequence. Describe is say what you see, but it's say everything that you see, including numbers, right? So that's the command word structure for describe. Say what you see, or what you would see with your mind's eye, but include everything, including numbers. So imagine you've got a graph with a maximum on it. So it's power against resistance of the external circuit, right? And you end up with a maximum, right? You've got to describe the relationship between power and the resistance, right? And it's a thing, right? A hump. Okay. Sorry, how do I get rid of it?
I don't know how you did it in the first place.
It's recognising my hand gestures.
Oh.
I know, it's annoying. Anyway, so how do you describe it? Well, you say that it goes up to a maximum and it comes back down again. The power goes up to a maximum and comes back down with increasing resistance. But that's only half your description. You have not described that graph unless you said where the maximum is in terms of resistance and what the maximum power is. You've got to give the point, the coordinates of the maximum. That's what I mean by describe, including numbers. Now you've properly described that graph, that relationship. Can you see? You've got to do what it says. And describe is say what you see. Right? But it's say everything, including numbers, and especially in physics, including numbers. And now you've got the command word structure for describe, and you've got the command word structure for explain answers. So now when you are looking at an explain, you should go, what's my key fact? What's my starting point? Is there an equation that I can pick? And that's often your starting point. And then you go, right, well, I have to say that. And then you go, well, I've got to say that as well. And sometimes it's describe and explain. Well, the describe is what happens to the potential difference across your thermistor. So you say, well, potential difference goes down. Well, that's the describe bit. That's bam, bam, bam. What? Ooh, they're on the mark scheme. Yay! Right, what's the structure for describe again? Are you ready?
Yeah.
Say what you see.
And if you can't think of it in your mind's eye, draw a little diagram.
Yeah, but it's not just say what you see, it's say everything you see, including numbers. So include the gradient of the graph, include a point on the line, include the maximum, include. And if it's a describe an experiment to show, right, you need a label diagram, you need the method, you've got to say what your independent and your dependent variable are, because you have got to describe the experiment sufficiently well that if somebody just as clever as you came along, they could follow your instructions and do the experiment. Imagine what your teacher would give you to get you to do the experiment. That's the quality of your describe an experiment to show answer. None of this mean little scrawny, scrappy little diagrams without rulers. No, draw it properly, a properly labelled diagram. Include all your measurement equipment. Include what's the independent and the dependent variable. Include your method. Include how you're going to measure resistance by dividing voltage by current. Include your empty table of data. Say how you're going to change your independent variable. Say how you're going to measure your dependent variable. Say how you are going to put these numbers into this empty table. Include in the table your units. Include the statement, I'm going to set my equipment up as shown in the diagram. Include repeat steps 1 to 5 in order to, and do it for at least 10 different values of the length of the pendulum or whatever it is you're changing, right? And then you've got to say what graph you're going to plot, how you're going to analyze it. And you are going to plot a graph. Almost always you have to say what graph you're going to plot and aim to plot a straight line graph, guys. So if you have to, for example, work out what an exponent is, plot a log graph for year 13. Just log it. Just log everything. You can do it. Most of you are doing maths. And then you have to say how you're going to get, I don't know, G from your gradient. Or the Young's modulus from your gradient, or the energy stored from the area under the graph, or whatever it is. Say how you're going to analyse it. And then for every one of your required practicals, you should have in your armoury of things 3 things for each required practical. How you can make it more accurate, how you can make it more reliable, how you can make it safer. You should have 3 things lined up for every one of your required practicals, because at least one of them is going to come up in your exam. Okay?
There's a couple of questions.
Couple of questions. Okay. I think at this point I'm going to have to stop teaching exam techniques. You can see that there are a lot. And you've got to crack them all. So if I want to go back and escape from there. Oh, escape. Escape from there. It was this work plan. So ninja question analysis we looked at. I didn't do walkthrough through the twist. I haven't done problem solving. I have done 2 command word scaffolds, explain and describe. I've told you where to go for improving your odds in multiple choice. We haven't managed to do 6-mark questions. I haven't really talked about the learning loop. I've sort of have. I might do that before we finish, and the timing I haven't managed to do. So you can see there are a lot of exam techniques that I haven't been through. Can I please go through 6 markers? Well, I kind of just whizzed through describe an experiment to show. Ugh, 6 markers have, it's already 8:30. Right, pop into the chat if you want me to go through 6 markers. Learning loop, yes. Timing, learning loop, timing again. Right, I think 6 markers is winning over timing, and I will mention the learning loop. Right, okay, so stop sharing. Right, learning loop, this is it. It's a 3-step process. Are you ready? First, do a paper, or at least a question, an A-level physics question. Okay, mark it yourself. And in marking it yourself, you've got to figure out for every question you didn't get full marks on, what was it you didn't know? Was it physics or was it exam techniques? Was there something that you'd forgotten about potential dividers or one of Kirchhoff's laws or something about gravitational potential? Or was it that you don't understand how to answer an explain question, or you have forgotten how to do a compare question, or it's a 6 marker and you didn't do everything that you're supposed to do for 6 markers? Okay, so do a question or a paper, mark it yourself, figure out what you don't know when you've marked it yourself, right? So do the paper, mark it, and figure out what you don't know. That's the second step. Third step, fill in the hole in your knowledge. So if it was physics, fill in the physics hole. If it was exam techniques, fill in the exam technique hole. Figure out the patterns in the words. What's the structure of, and a compare. Compare is, say, X is like this and Y isn't like this, and X is like this and Y is like this, and Y is like this and X isn't like this. And you have to mention both of them all the time when you're comparing. Okay, you've got to, right, it's written in English, guys. You just have to know what the words mean, right? You have to know what the words mean. Right, now, that is the learning loop. 3 steps. Do a paper, figure out what you don't know, fill in the hole in your knowledge. Go back, do it again. Paper, figure out what you don't know, fill in the hole in your knowledge. Oh, paper, figure out what you don't know, fill in the hole in your knowledge. And I promise you that it's less often physics and more often exam techniques until you've got the exam techniques down. And you can they're only like half a dozen. You've got to fill them all in, fix it. And then suddenly your grades go scooting up because you know how to answer the questions. Okay. Do I have a bank of command words of exactly what they mean? Yes, I do. It's in my exam techniques course. What's the biggest piece of advice for structuring 6 mark questions? Okay, we'll come to 6 mark questions. So there's the learning loop. I've talked about that. I'm not going to talk about timing. Haven't got time. What we are going to do briefly, I'm going to do a 6 mark question. So let me, right, the 6 mark questions are really good on the OCR course. The AQA 6 mark questions, they've got them in the AS. All of the the proper full-blown A-level AQA 6 mark questions are on the option topic paper. So I'm not going to do an AQA one. I am going to do an OCRA 6 mark question. They're mostly on paper 2, so I'm just going to randomly pick a 6 mark question off the OCRA exam board. Right, OCR, come on. Right, let's go for 2018 again. We want paper 2, so exploring. Okay, there we go. And let's make it a bit bigger. Right, so let's find the 6 mark question. There's 2 of them, nearly always. So we're going to scoot through until we find them. Multiple choice. There it is. 6 mark question. Okay, so, and it's about a circular metal plate, and we've got a light from a lamp shining through a hole, look. Okay, and there's a light dependent resistor underneath, and the data logger is across a fixed resistor. Oh, look, it's a potential divider. And we've got a potential that's changing with time, because as the disk rotates, the light hits the light dependent resistor, it changes the resistance of it, and the voltage across the fixed resistor goes up and down. Right, okay, that is the question. Right, let's have a little look at the 6 marker bit. Okay. Use your knowledge and understanding of potential divider circuits to explain. What's the command word? Explain. We have to explain the shape of the graph. Right. What else does it say? There's another command word. Describe. Good. There's another command word. Use your knowledge, not really a command. Determine, yes. Include, yes. Oh, now you're looking for the command words. Can you see how valuable this is? Right, now, you have to follow every instruction. You must explain the shape of the graph. You must include the maximum and minimum values of the LDR. You must describe how the student can determine the frequency of the rotating plate. You must do everything. Right, now, what I'm going to do now is I am going to write subheadings. I'm going to write down explanation of the shape of the graph. And I'm writing that down because I absolutely have to have that, or I certainly won't get 6 marks because I've been told to put it in. Right, I've got to include in my answer the maximum and minimum values of the LDR. So my next subtitle is calculate max and min R for LDR. Okay, that's another subtitle. That's another thing that I absolutely must do. Right, now the next thing I've got to do is to describe how I can determine the frequency. What's the word determine mean? I have to look at use the graph. I've got to use the graph. Oh yes, use the graph. Okay, so the next title, subheading is determination description of the frequency. Okay, and I'm going to put using a graph. Right, okay. Now, can you see I've got 3 subheadings? Can you see how I'm going to get my 6 marks? Is it possible that you could now at least have a stab at each of those 3 instructions? 2 marks for each point? Yeah, why not? I mean, probably there's more than 2 bullet points. So what we're going to do now, I mean, I'm not actually going to answer this, but what we're going to do now is we're going to have a quick look at the mark scheme. But what I want you to take away, this is just a blast through 6 mark questions, but really what I want you to take away is there are instructions. There are 3 instructions for this question. You've got to explain the shape of the graph. And so the explanation of the shape of the graph is going to be on the mark scheme. There's a 1-to-1 relationship between what it's told you to put and what's on the mark scheme. They've told you to calculate the maximum and minimum values for the LDR. So guess what? The maximum and minimum values for the LDR are going to be on the mark scheme. For sure. If you don't put them in, there's no way you can get 6 marks. And then, 1-to-1 relationship, you've been told to describe how you can use the graph to determine the frequency. So you've got to describe, and if you do the description of how to work out the frequency from the graph, you're going to see those on the mark scheme. Right. We're going to have a look at the mark scheme. I promise you those 3 things will be there. And there's going to be little bullet points under each of them. But those 3 things, I promise, and I haven't looked at this. I mean, it was random. I haven't looked at this question. It was random. Okay, so this is question 17, and it was paper 2 from 2. Right, let's find it. Mark scheme, exploring. No, that's a erratum. There it is. Right. What was it? Question 17 after the multiple choice. Multiple choice. Question 16. Question 17. Oh, look. Explanation, description, calculation. Explanation, description, calculation. Even the headings are the same. The trace mentioned is that one, that graph. That's a trace. Okay. Right, do AQA papers have 6 markers? Yes, on the option topic, paper 3B. Okay, they also have 4 markers and occasionally 5. Okay, last year there were 2 5-mark calculation questions. Right, is there a trial 1-to-1?
I've never an answer.
Okay, right, 2. Right, has anybody got any questions at this point? I'm going to stop. I have to stop. I hope that this has helped you. I really hope that this has helped you. Right, let me go back to my my thing, because at this point now, go get your parents, because what we're going to do now is I'm going to give your parents some advice. I did promise that I would, and I'm going to do it. So so back to my my PowerPoint. So this is the learning loop. I've mentioned the learning loop. Do some questions, find out what you don't know by marking it and figuring out if it's exam technique or physics. Fill in the right hole. Fill in the marking, so the exam technique, or fill in the physics bit that you didn't know. Fill that in. That's the 3 steps. And then go back and do it again. Okay, and every time you move yourself up, but the thing that people miss is filling in the hole. That's the bit that they miss out, and they fill in the wrong hole. They think it's physics that they don't know, and it's not. It's exam techniques. Okay, so learning loop. Right, so that's the learning loop. Right, bits and pieces. Learn your data sheet, learn your specification, use your engineering button. I don't know if any of you know about this, but there is your engineering button. Some graphical calculators, they have to go into menus and find it. It's really useful. It puts things in times 10 to the 3, which means that you can use prefix. So milli is times 10 to the minus 3, and micro is times 10 to the minus 6, and giga is times 10 to the 9, and so on. It makes it really, really easy. You never have to count decimal places or place values again. Just press your engineering button and it puts it in the nearest factor of 10 to the 3. So it's a bit like standard form, but not quite. Puts it in factors of 10 to the 3. Okay, so that's really, really helpful. What else? Okay, check if you're in radians or degrees on your calculator. Most of the time you need to be in degrees, but not always.
Big difference between radians and degrees.
Oh yeah, 1 radian is about 60 degrees, so it's almost 2 factors. Or,
don't make that mistake.
Factors of 10 out. Yeah, don't make that mistake. Use a pale highlighter pen to highlight in a question, but not in the answer. Not allowed to use it in the answer. Read the examiner's reports. The examiner's reports tell you what most people got wrong. And I don't know about you, but I think that's useful stuff. So, oh, what happened there?
That's interesting.
Yeah. Oh. Let's try again, shall we? Try again. Try again. Da 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 da. Okay.
Did you somehow press escape?
I don't know what I did. Right, and we've got on to advice for parents. I hope you've managed to get your parents in the room. I'm going to carry on because we've got quarter of an hour. Right, okay, so this is how parents can support their child or student in the run-up to exams. Okay, you need a quiet, comfortable place to work. Not too hot, not too cold, not too noisy, preferably with a proper desk. But you should practice doing papers in under exam conditions. So no phone, no music, no interruptions, do it timed, have your data sheet to hand, no books, yeah, you should do it under time conditions, because it is a skill, another exam technique you need to get good at. Okay, so healthy snacks. It's very tempting to eat biscuits, especially chocolate. Carrot sticks, really good. Fruit and nut bars is quite good. But healthy snacks, and use the same healthy snacks when you're revising as you're going to use in the exam, because smells and tastes can also remind you of things, help with your recall. Fitness. Don't become a sort of recluse. Don't sit at your desk for hours and hours, and don't go outside and see the sun. Make sure that you don't give up all of your sport. Obviously, you know, if you're the sort of person that plays football every night, you might not want to do that. But, you know, a couple of times a week, you definitely need to, you know, sort of run around the block, or, you know, take your dog for a walk the way you normally would, or go and play badminton the way you normally would, or whatever it is that you do. Yeah, don't stop completely, because if your body is fit and well and everything is working, your brain will be too. Mustn't stop everything. Okay, so if you do struggle with anything, whether it's physics or exam techniques, or anxiety in the exams, or you've got a chronic health condition, or there are problems with somebody else's health condition in your family that's affecting you, or whatever it is, seek support from the school in the first instance. Your exams officer will, I mean, they're mostly so nice. They're on your side. They want to help. So ask for help from your teachers, ask for help from other students, ask for help from other parents. Almost certainly there's somebody else who's going through it too. Yeah, so your first port of call is the school. So that's quite important, right? You mustn't go nocturnal, especially if you get study leave. It's very easy to wake up late, not want to get out of bed, start studying, you know, sort of 4 in the afternoon, and then think, oh, I've got to go on till 2 because I didn't start until late. And then you go to bed at 3, and then you don't get up until noon, and then it's like later. And before you know it, you're getting up at 4 in the afternoon, and you're going to bed at 5 in the morning, and you're awake all night. And then you're expected to get up and be ready and functioning for an exam at 9 o'clock in the morning? I think not. So don't get up late. Basically, a parent can kind of kick them out of bed, make them walk around the block, and then do some work. They've got to get up. They must be functioning during the day, which is when they've got to be functioning for their exams. So yeah, good sleeping habits, really important. Yeah, so don't go nocturnal. Stress reduction, right? If you have anxiety, if your anxiety is serious, you need to seek medical help, and you need to do it soon.
Genuinely, it makes a lot of difference, and if you can get it's not extenuating circumstances, adjustments, what are they called? Gosh, I should know.
Access arrangements.
If you can get access arrangements, or if you're eligible for access arrangements, if you can practice with them and know that you're going to have them before the exam, and then you practice with them, that will set you up for the best possible scenario when you actually do the exams.
Yeah, so if your anxiety is very serious, then they might give you rest breaks, or they, and so on. It's worth investigating now. You don't want to leave it until like 5 minutes before the first exam before you actually seek help. So yeah, there are, I mean, 7-11 breathing is where you breathe in for 7 and out for 11, and that actually gets rid of the carbon dioxide out of your lungs, which brings down that panic feeling. When you panic, you don't breathe deeply, and you can't get rid of the carbon dioxide, and that makes the panicking worse. And so there are things that you can do that will help you. If homeopathic remedies work, my sister was an exam phobic. And she really struggled.
She's an exams officer now.
Yeah, but she really struggled, and she had a homeopathic remedy of drops. I mean, I don't think they did anything, but the placebo effect is real, guys. So, you know, anything that works, yeah, figure it out. Of course, the best stress reduction technique is being really well prepared for your exam and absolutely convinced that you're going to fly it. That's the best stress reduction. You don't panic then, but it's, yeah, if you can get to that point, that's fab. And yeah, and then you just have to show off, right? It's the one occasion you can properly show off if you're really clever. Okay, right, have a good breakfast. You need brain food. Have a good breakfast, preferably slow release carbohydrate. So anything with, you know, complex carbohydrates, starch. So beans on toast, or eggy soldiers, or bacon sandwich is great. A banana is great. Anything with slow release carbohydrate, preferably with protein as well. And then snacks that don't rustle and that have no wrappers on to take in.
Always bring it in Tupperware and take the lid off at the beginning of the exam, because before anything started, because you're not allowed to have packaging and rustling noises during the exam.
Yep. Okay, so get to the exam early. You're much better waiting for half an hour before your exam starts than risk getting there late, and then stress levels are sky high, and or you have to ask for you know, special consideration because you arrived half an hour late because there was a traffic jam, because somebody crashed into somebody else, and you just don't be in that position. Get to the exams early, and parents often drop their children, especially in exam season, and yeah, so just get there early. Don't risk it. Keep things in perspective. It's very, very easy, especially at the end of 2 years of A-level study, to think that your A-levels become everything. You're blinkered into thinking that the whole world is all about A-levels, and it's absolutely not. And there are always options, always options. So yeah, keep things in perspective. Bear in mind that there will be options. Even if the worst happens, there's always options. Right, now, UCAS, it's a bit early to be talking about UCAS for year 12 and a bit late to be talking about UCAS for year 13. I don't want to say much about UCAS, but from the point of view of the year 12s, you need to be thinking about your personal statement, and you need to start fairly soon collecting your evidence, the things that you're going to put into your personal statement. So you need to think about what you might want to include and what sorts of things you can include. I would do most of your investigation into UCAS over the summer if I were you. But yeah, you need to know the deadline dates. They are early for the top flight universities. So and if you're applying for medicine or veterinary, it's usually the 15th of October for Oxbridge, and if you want to do the Imperial entrance exam, for example, the early one, there is a later one that's at the end of January, beginning of February. But the earlier you can apply, the better, really. So know the deadline dates. Record your extracurricular activity, anything that you are interested in that is not your schoolwork, that makes you you. The things that are unique that otherwise the examiners, the admissions registrars wouldn't know, unless you tell them about you, right? So yeah, all of these sorts of things. The support. Seek support for UCAS in particular. There should be a teacher that is particularly good at navigating UCAS, and find out who they are and get help. Usually you get your UCAS login May for year 12. So if you haven't had it by kind of summer half term, ask for it. Okay. Apprenticeships deadline dates are different to the deadline dates for applying to university. So, and at all the different apprenticeships, they all have different dates. You need to go looking, and you need to be aware of that, and that you need to go looking. Consider not applying until the following year. So if you're in year 13 and you've decided to have a year out, I applaud you. I think that is a good thing to do. There are a few courses where that is frowned on. If you want to go and do maths at university, I mean, I know for sure Oxford won't take you if you insist on a gap year. They just won't have you. They think that the younger you are, the better, really, from maths point of view. So so be aware that not every university will encourage gap year, certainly for some subjects, but for most subjects I think having a gap year, a year where you can decompress, a year where you can get bored, where you can learn the value of getting out of bed and going and stacking shelves in Tesco every day for six months, is a valuable learning. and it stops you from thinking about A levels, and your academic journey becomes much more attractive afterwards, and so on. So you need to look about what goes into a personal statement, right? There are lots and lots of possible things that you can do. There are almost limitless options open to students, especially A-level physics students, especially because you're really bright. You can do almost anything, guys, almost anything. Okay, things other than A-levels count towards UCAS points. You probably know about EPQs, but also music and drama qualifications count. Singing, yeah. You don't have to go to university straight away. You can apply now and defer for a year. Quite often, does depend on the course, does depend on the university, but you can choose not to apply at all, and then your place doesn't depend on your A-levels, and then when you are applying, you know what your A-level grades are. There's none of this predicted grade to sort of worry about, well, will I get that or not? You don't have to take your place up straight away. Even if you said you were going to take it straight away, you can then change your mind. Okay, you can have a proper safety net. Really, really important. One that's significantly lower in grade. That has to be a proper second choice. So somewhere where you actually genuinely want to go. So don't pick as a safety net a course or a place you actually don't want to go and live. That's not a safety net. That's putting up with second best. That's not what it's about. Yeah, consider a gap year. There are sponsored apprenticeships and foundation years. The foundation year is almost always better idea than resitting. Consider carefully the type of university as well as the learning environment. So campus versus city. London accommodation is very expensive, but if you've got family who live in London, maybe that's an attractive thing from your point of view. Consider the environment as well.
Well, and also how practical it is as well. Like how many hands-on hours you get with tutors, lecturers and stuff like that. It makes a really big difference.
Yeah, she's speaking from experience. Megan was on a performing arts degree in the middle of COVID. Can you imagine that?
Wow.
Yeah. Anyway, right. Keep things in perspective again. Right.
We've had someone thoughts on foundation year.
Okay. What about it? They want mine.
They want your thoughts on foundation year.
My thoughts on foundation years. Right. If the worst comes to worst and you don't get the grades that you need to go to the university of your choice, then doing a foundation year, it is, and maybe you're not slated to get very good results anyway, and a foundation year is where you're aiming, and a foundation year is actually, I mean, my personal view is that it's a much better option than resitting. The problem with resitting is that you're setting yourself up to fail. The chances are that all the things that meant that you failed the first time, they're still there. And now you are expecting yourself to improve your grade without the benefit of being in school, without the homework that the teachers are setting, without the motivation that the other students in cohort are not there to support you, and yet you're expecting to improve, really. So nearly, my experience, even with the best will in the world, most people who resit actually don't improve their grade. And what I would recommend you do instead is do a foundation year. Once you're in the university, they're very loath to lose you, so they want you to carry on. It's in their interests to support you, to make you succeed. And so going to university and having a foundation year, if you need it, obviously if you don't need it, it's fine, but if you need it, then I think that that's a much better option than resitting. Okay, so that's my thoughts on foundation years. Okay, right, I think that is it.